In Chapter 6, we're going to look at some additional useful techniques. There are a couple of them that we will do from the simulation button. If you click the down arrow, you get advanced analysis. So we're going to look at advanced sensitivity analysis and stress analysis. And then we're going to look at, we've so far been doing parametric probability fitting parametric probability distributions. Parametric probabilities means defined theoretical probability like binomial or Poisson or normal distribution, things like that. Now, what if such a distribution doesn't really reflect the underlying data? Because the underlying data is kind of so different from any of the parametric distributions, then how do we deal with that? And also cases where we have different probability distributions in different data ranges. Okay. Now we can stitch together several parametric distributions, okay, one for each data range, and then that we can use that stitched up parametric distribution for simulating the underlying input. So those are the kinds of topics we're going to look at. So we're going to start with advanced sensitivity analysis, and here it is going to be somewhat similar to this risk sim table that we did. In risk sim table, we look at one input and then say, okay, here are the possible values that I want to run the simulation with. And then if you have more than one, then all these combinations will have to be listed out by ourselves. And then we run the simulation. Now, advanced sensitivity analysis makes it easier to set up more than one input. Well, even if it is just one input, and then we can select some input values based on more than just actual alternative value input values, but you can set up like percentiles and things like that. So it gives you some more flexibility in terms of what a kind of scenarios that we can run. So it's more like a scenario analysis, and it's very flexible for developing or setting up different scenarios. So we're going to go back to, and that's important because like tornado charts, they rank the input by uncertainty. What is the largest uncertainty, second largest uncertainty with respect to the variability in the output? And usually it doesn't tell you exactly what happens or what uncertainties are in a particular data range. And usually in the tail areas, okay, extreme values, extremely low value, extremely high value, how the output will react. It's kind of hard to tell because tornado charts are fixed at 10 percentiles. It takes 10 percentile intervals of the input values from the lowest value to the highest value, and then runs the simulation. But advanced sensitivity analysis, permits us to provide input ranges that we want, custom input ranges, not a fixed 10 deciles, 10 in 10 percentile increments. So let's get into an example. So this is the movie pass example from way back in chapter 2, and that's what we're going to look at. And there are three input variables. What is the increase in number of movies that the customers will go to, given that they have purchased a monthly pass? Then the second one is a consumer sensitivity for purchasing subscriptions. So the people who watch more movies per month, as of now, are more likely to purchase because there will be a cost saving for them. And then the people who don't watch a whole lot of movies, they are less likely to. So there's sensitivity there in terms of where the customers are right now in terms of their movie watching preferences. And then of course there is a third variable which is not really uncertain variable, but it is a variable that we need to negotiate with the theater owners in terms of the purchase admissions price that we have to pay when one of our customers shows up and watches the movie. Okay, so let's look at the model. Okay, so this is the model. We have we've already gone through this before. So we have 4 possible values that we want to test out for the admissions price. Yeah. And we have right now we have a risk sim table right there. Let's just make it the default value of 9, and let's get rid of this. Okay, so that's one input, and then these two are the variable inputs. Okay, and we want to run the simulation, okay, by setting up those scenarios. So go to simulate and go to simulate. Before we get into that, let's make sure that the settings are okay. So automatic and fixed. Okay, so this is good. So now go to simulate and then advanced simulation analysis. Now we set up the cell to monitor. Okay, we want to monitor the profit. So J28 is what we want to monitor. And then we add scenarios here. Okay. Now in scenario management, we have to input the scenario values ourselves, but here at risk allows you to set up those scenarios in a much more flexible way. So we can select distribution based input or cell based input. Okay, you can enter the different values in cell, which you've already seen. So distribution based input, okay, then distribution percentiles are automatically set up. So what this will do is whatever input location that we select, okay, so let's select that one, E12. Okay, of course, in your textbook it will be B12. Here we've made a small change here. So it'll be that. So the scenarios that you'll see here is it'll take the distribution and then use the first percentile, 5th percentile, 25th percentile, all the way through 99th percentile. And you can change these percentile values. We'll just select, accept the defaults. So those are the different percentiles that will be used for each scenario. Okay, and let's do the same thing. Okay, for the next one, which is that consumer sensitivity analysis. Okay, and again we have the same percentiles. Okay, and click OK.